Hi there, welcome once again to my channel. Today I'd like to discuss a topic that is related to advanced natural products. The topic is steroids. You know that about uh, if you'd like to know about steroids in detail, or if you'd like to get the insights about steroids, then this video is really helpful for you. So guys, without any delay, let's get started. There are different kinds of basic skeleton that you have to know before knowing in detail about steroids. The number one you can say naphthalene. We also know about naphthalines. Naphthalene means two benzene ring when connected with each other or fused, then that is called you can say naphthalene. It is the anthracene when one extra benzene ring will be attached with uh, naphthalene, attached to naphthalene, then it will be from phenanthrene. Similarly, this structure, it's a you can say basic structure of this portion. Up to this portion is phenanthrene, but when cyclopentene group is attached, then that compound will be one two cyclopenteno, not pentano, penteno phenanthrene. It's a you can say if you like to give the number, and it's another branch is attached here. It's a methyl group attached in 3' position. So we can say that it's the name of this compound will be 3' methyl 1,2 cyclopenteno. It's not the pentano. It's a cyclopenteno phenanthrene because this portion is phenanthrene. Up to this portion is phenanthrene. And it's a parhydrophenanthrene. When double bond will be banished from the phenanthrene, then the produced compound will be parhydrophenanthrene. That means in this specific compound there is no any double bond. Each and every double bond from phenanthrene will be banished, and the produced compound will be you can say parhydrophenanthrene. And this compound is the similar, but in this compound there is no any double bond, but in this compound there are 1 2 3 4 5 6 7 8 eight double bond eight double bonds are present. So that's the difference. When you'd like to added hydrogen, double bond will be break down and hydrogen will be added, and the produced compound will be you can say 1 2 cyclo pentano. It's not the pentino. It was pentino because this is specific cyclopentane group contains double bond. You know that about alkene, methane, ethene, propene, butene, pentene. From this specific portion, we have got this specific name. That means cyclopentino. It will be the cyclopentano. It's not the pentino because in this specific portion or cyclopentane there is no any double bond. That's why the compound name will be this portion name will be cyclopentino. If you'd like to give the number, it's a 1, it's a 2, 1 2 cyclopentano parhydrophenanthrene. It was parhydrophenanthrene. This portion will be parhydrophenanthrene because in this specific portion there is no any single double bond. So that's the thing. And the compound name will be you can say if you'd like to give number 1 2, and this carbon will be you can say 1 prime, this carbon will be you can say 2 prime, and this carbon will be you can say 3 prime. So actually this methyl group attached with 3 prime, so we can say that it's a 3 prime methyl cyclopentano 1 2 cyclopentano parhydrophenanthrene. So that's the name. In this way we'll be able to nomenclature, we will be able to give the name of any compound of any skeleton. So that's the thing. In the next portion, that is called the, you can say gunen type skeleton. Gunen means three A B C. It's the three benzene rings, and D, the level D portion, that is known as you can say cyclopentane ring. So we can say that gunen is a you can say simplest steroid. Guanin is a simplest steroid and the nucleus of all steroids and sterols. It's the nucleus of all sterols and steroids. So we can say that guanine is synthesized or formed by means of combination of or fusing of three benzene rings and one cyclopentane ring. That is called, you can say, guanine. That is the simplest steroid and the nucleus of all steroids and sterols. So that's the thing. And the next portion, if you'd like to know about the definition of steroids, we can say uh, steroids, any of a large class of fat-soluble organic compound, but cannot be hydrolyzed by sodium hydroxide. So we can say that steroids is a one kind of uh, fat-soluble organic compound. That means those compounds which are soluble in organic solvents, but cannot be hydrolyzed by sodium hydroxide. Such compounds are known as, you can say, steroids. So that's the definitions of steroids. And the next one, we know that about the steroids in which Gunin type basic skeleton that we have already known about Gunin type skeleton. That means in steroids we will be able to find Gunin type skeleton. That means Gunin type skeleton means we can say that in the Gunin type skeleton, three six-membered benzene ring, three six-membered benzene ring, and one five-membered cyclopentane ring will be fused with one another. That is called the, you can say, Gunin type skeleton or Gunin. Uh, so steroids is a any of a large class of fat soluble organic compound, any of a large class of fat soluble organic compound, but cannot be hydrolyzed by sodium hydroxide. It's a base, so we can say that that's the definition. And with a characteristic Gunin type skeleton, uh, three six-membered and one five-membered fused rings, and most of which have specific biologic physiological actions termed as steroids. That is the keywords you have to keep in your mind to define the term steroids. That means fat soluble organic compounds and cannot be hydrolyzed by sodium hydroxide, and it has characteristic gonad basic skeleton and physiological actions, specific physiological action. So these are the, you can say, features, these are the keywords to define this term steroids. That's the thing we know that about. Steroids include many hormones, sterols, bile acids, alkaloids, and vitamins. So they can include different kinds of things. I have already told you. So keep in your mind uh, the number, you can say, it's a cholesterol. How can you draw this structure of cholesterol? First of all, you have to draw the structure of guanine. It's a guanine. I have already told you three six-membered benzene ring, one five-membered cyclopentane ring. That is a Gurin type skeleton. If you level this skeleton, the basic skeleton of this structure of cholesterol, A, B, C, it's a D. That means first three benzene rings level by AV3, and the fourth, or you can say the last ring, that is level as D. So you have to keep in your mind that in the cholesterol structure, B B ring contains a double bond. It's a double bond. B ring contains a double bond. It's a double bond. And A ring contains, you can say, hydroxyl group or hydroxyl functional group. So that's the attached things or attached extra things, and this portion contains a methyl group. That means in the junction point of A and B, one methyl group will be attached, and in the junction point of C and D, one with another methyl group will be attached. And in the upper portion of cyclopentane ring, we will add a chain. It's a alkyl chain. How can you level this alkyl chain? If you'd like to level, it's a one. You can say it's a, you can level in this way: one, two, three, four, five, six. It's a seven. So we can say that it's a 2 methyl, 2 methyl heptyl. So we can say that if you'd like to give the number, it's a, you can say 1 2 1 prime 2 prime 3 prime 3 prime 3 prime 2 methyl heptyl 1 2 3 4 5 6 7 3 prime 3 prime for these positions. That means B ring contains alkyl chain, and that is attached with these positions of D chain. So we can say there is a 3 prime, uh, 2 methyl haptyl cyclopentano, 1 2 cyclopentano, 1 2 cyclopentano. That's the thing, the Gunin type skeleton. And in the Gunin type skeleton, you'll be able to see it's a methyl group. And here it's another double bond. Here it's a hydroxyl or alcoholic group. That's the extra you can say features you have to add to draw the structure. So that's the thing. And it's the lanosterol. Lanosterol structure is not the critical things. You have to again draw a Gunin type skeleton. First, you have to draw three benzene ring, and one cyclopentane ring, and you have to add. If you'd like to label A, B, C, and D, that means A, B, C, D. You have to label. Then after labeling, you have to give a double bond here in the junction point of B and C. That's your task, that's your primary task. And after labeling, you have to add this one methyl group in the junction point of C and D, one methyl group in the junction point of A and B, that is as like as you can say cholesterol. And you have to add hydroxyl group, that is as like as you can say cholesterol. And you have to add here again you can say aliphatic chain or aliphatic you can say chain. If you'd like to give the name of this compound, it's a 1, it's a 2, it's a 3, it's a 4, it's a 5, 6, 7. That means it's also 7. If you'd like to give the name of this side chain, you can say it's a 2 methyl have 2 in have 2 in have to in. That means you can say if you like to give the if you like to give the name of this compound, you can easily uh, naming the compound. And in this portion uh, that contains a hydroxyl group, but you have to add some extra features, extra group in this portion of cholesterol. And you have to remove two hydrogen, and you have to replace two hydrogen by two methyl group. I have already replaced two hydrogen by two methyl group, and then you will found lanosterol. What's the difference between lanosterol and ergosterol? You will be able to see there is no more changes in the structure of ergosterol. It contains also a Golentab skeleton, three benzene ring and one cyclopentane ring, and the double bond is you can say in this portion, in this position. So you have to keep in your mind that double bond in case of ergosterol here, and one methyl group is added in the junction point of AB and CD ring. And in this position, so you'll be able to see that that contains a hydroxyl group. Also cholesterol and lanosterol contains hydroxyl group in the same position. And if you'd like to see here hydrogen, you can say it's one hydrogen. You can show, you can by a dotted line, you can also show one hydrogen. It's really up to you. And you have to add a side chain. How can you name this side chain? 1 2. If you'd like to give the number 1 2 3 4 5 6 7, it's a 7. You can say it's a 7. That means a side chain that contains 7 carbons, and one side chain, you can say this is the side chain, and 3 that also contains a side chain. And that means two side chain is added in the aliphatic chain. You can say the name of this portion, you can say 2,3 dimethyl hapt 4 in. That's the name of side chain, and other things will be as usual. And in the ergosterol, you have to keep in your mind that ergosterol you have to add you have to add two double bond here, double bond, one double bond here, another double bond. One double bond is in this position, that is uh, as like as cholesterol. and one double bond is in this position, that is totally different from these two structures. So you have to keep in your mind that these two double bond you have to add. So that's the overall structure of some steroids or sterols. If you'd like to know about this kind of things in detail, so you have to know actually steroids. We know that about lanosterol, argosterol, cholesterol are found in prokaryotic membranes, lower eukaryotes. Prokaryotic membranes means you can say uh, pro means you can say prokaryotic membranes, lanosterol and ergosterol and cholesterol. Those are found in prokaryotic membranes, and lower eukaryotes like fungi. Fungi is the term that is plural form of fungus, and as a major component up to of the plasma membrane of mammalian cells, and component up to 50 mole percentage of the plasma membrane of the mammalian cells respectively, with crucial roles in the organization, dynamics, function, and sorting in these assemblies. So that's the thing actually you can say. Dials hydrocarbon. How can you find dials hydrocarbon? It's you can say steroid. It's this is the steroid, and this is you can say selenium. It's a 360 degrees Celsius temperature. When you'd like to do uh, reactions, when you'd like to perform reactions in the presence of selenium catalyst at 360 degrees Celsius temperature, steroid will be converted into this compound. This compound name you can say, if you'd like to give the number 1, 2, 1 prime, 2 prime, 3 prime, that means you can say that it's a 1,2 cyclopentene, or you can say 1,2 3 prime methyl cyclopentene. It's a you can say phenanthrene. That's the compound. By means of hearing steroid in the presence of selenium, will be able to get this compound. Or you can give you can give the compound different nomenclature. It's really up to you. You can call 3 prime methyl 1,2 cyclopentano. It's a pentano, not pentano, because it contains a double bond related compound called as you can say alkene, in tin tin pentene hexene, like this. So we can say that it's a cyclopentano because this compound is cyclic, so it's a cyclo. And this portion, this ring contains five member or five carbons, so it's a cyclopent. This compound contain, this ring contain double bond, so it will be in cyclopentino, cyclopentino. And this specific portion is called the you can say phenanthrene. So that's the nomenclature. And you can also nomenclature, you can bring this 1 to this number in the preliminary position, and you can swap this position 1 2 and 3 prime methyl cyclopentino. Cyclopentino, it's look like this nomenclature. um, but just we have swapped in this 1 2 position with these 3 prime positions. So that's the thing. And you can also give the number of this compound 17 methyl. If you like to give the number 1 2 3 4 5 6 7, 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17. It's a 17 methyl. This position is will be 17. 15 16 dihydro, 15 16 dihydro. That means this two position contains one extra hydro, so say 15 16 dihydro, 17 hydrogen, 17 hydrogen cyclopenta, cyclopentra phenanthrene, cyclopentra phenanthrene. So that's the nomenclature. You can call in different way of this compound. So that's the thing. And we can say that a cyclopentanophenanthrene derivative with molecular formula C18H16, a cyclopentanophenanthrene derivative with molecular formula C18H16, obtained by the dehydrogenation of various steroids is termed as dials hydrocarbon, and its melting point is 126 to 127 degrees Celsius temperature. cyclopantenophenanthrene that we have found by means of heating of steroid in the presence of selenium. Then we have found this compound. At the melting point of this compound is 126 to 127 degrees Celsius temperature, we can say. uh, and its structure is confirmed. The structure of cyclopentanophenanthrene that I have already showed, it's confirmed by infrared spectroscopy and oxidation and crystal analysis. By means of these three process, and the final confirmation is done by means of synthesis. So we can say that the structure of any compound that have produced by means of any reaction, we have confirmed by the following procedures. Number, you can say IR spectroscopy or infrared spectroscopy, and the next one that is called the, you can say, oxidation, and that is called the, you can say, crystal analysis, and finally by synthesis. So these are the steps you have to follow, and you'll be able to confirm the structure of any compound. So guys, this is all about today. Thank you for watching this video. Stay tuned. Stay, that is also called the, you can say, a dials hydrocarbon. This is the dials hydrocarbon. So it's not the critical thing. So if you have any questions that is related to this topic, you can comment in the comment box, without any hesitations. I will try my best to assist you by means of sharing my accurate knowledge, so that you'll be able to get proper insights about this topic. Thank you, guys.